Welcome to the Bodhi Academy. My name is Amsha Klasso, and in today's video we will continue with our chapter 1 of solutions. So previously in this we spoke about homogeneous solutions. We also discussed what are binary solutions. Then we discussed how we can quantitatively find a concentration of these different solutions. So in that we learned various methods and their formulas to derive the same. Now in today's class we will talk mostly about solubility. So solubility of a substance is its maximum amount that can be dissolved in a specific amount of solvent at a specified temperature. So solubility of a substance, it is given by what? Maximum amount that can be, if we talk about maximum amount, we can say that how much of solute can be dissolved in a given solvent at a particular temperature. Okay. So it depends upon the nature of the solute and the solvent as well as the temperature and the pressure. So now solubility depends on four factors. First is the nature of solute, nature of solvent, then the temperature, and lastly the pressure. Now let us consider the effect of these factors in solution of a solid or a gas in liquid. Now solubility of a solid in liquid. Let's talk about the solubility of any given solid in any liquid. So every solid does not dissolve in a given liquid. See, if we take an example now, say we have sodium chloride. Now sodium chloride, when I say, it is an example of common salt, and we have sugar. Now these two, they readily dissolve in water. Okay, but if we look at naphthalene and anthracene, they do not readily dissolve in water. But naphthalene and anthracene, what happens is that they are readily dissolved in this thing, benzene. Okay, but if you try to dissolve sodium chloride and sugar in benzene, it is not dissolved, it won't dissolve. So it is observed that from this we can conclude that the polar solutes, they dissolve in polar solvents. So anything, polar solutes will be what? Which has some kind of polarity, that is, they can dissociate into the ions and give some polarity to the entire solution, correct? So in that case, what we can say, that the polar solutes which are there, they will dissolve in what? The polar solvents, and the non-polar solutes which are there, they will also dissolve in non-polar solvents. So it is like dissolves like. In general, a solute dissolves in a solvent if the intermolecular interactions are similar in the two. So if the solute and the solvent has a common intermolecular interactions, only in that case what we can say, that the solute will dissolve in the solvent, or we can say that like dissolves like. Now when a solute is added to the solvent, some solute dissolves and its concentration increases in solution. So now if we take, now say we have water. Okay, in that I'm going on adding solid solute, that is sugar. Okay, so as and when I'm adding sugar, what will happen? I will dissolve it, and what will happen? The concentration of sugar in that water, it will increase. This process, that is known as dissolution, wherein you are dissolving something in the solvent. This process is known as dissolution. Now some solute parts in the solution, they collide with the solid solute particles and get separated out of solution. So what they are saying, now some of the solute particles which are there in the solution, what they will do is that they will go and collide with the solid solute particles which are there, and that will get separated out of the solution. Now this process is known as crystallization. So you are adding some solute particles, these solute particles are then going and colliding with one another, and then they tend to separate out, and those separated out, we get them in the form of crystals. So this process is known as crystallization. So finally a stage is reached when the two processes occur at the same rate. So what is happening? Dissolution and crystallization is occurring at the same rate. Under such conditions, number of solute particles going into the solution will be equal to the solute particles separating out, and what will happen? We will reach a state of equilibrium. So solute plus solvent will be equal to the solution. Now at this stage, the concentration of solute in solution will remain constant under the given conditions. So and that is temperature and pressure. Similar process is followed when gases are dissolved in liquid solvents. So same thing happens when these gases, they are being dissolved in different liquid solvents. Such a solution in which no more solute can be dissolved at same temperature and pressure is called a saturated solution. As in, you have been going on adding and adding and adding. After one point, what happens? Nothing more is getting dissolved. Okay, it is going inside and it is remaining as it is. That is the saturated solution. An unsaturated solution is the one in which more solute can be dissolved. In unsaturated is opposite of saturated. So even if I am adding, it will get dissolved. Means the solution is still unsaturated. The solution which is in dynamic equilibrium with undissolved solute is the saturated solution, and it contains the maximum amount of solute that is dissolved in a given amount of solvent. Thus, the concentration of solute in each such solution is its solubility. Now, let's see what is the effect of temperature on solubility. So, the solubility of a solid in liquid is significantly affected by temperature changes. So, there is the solubility varies a lot with the change in the temperature. Consider the equilibrium represented by equation 1.10. This being dynamic equilibrium must follow the Le-Chatelier's principle. In general, if any nearly saturated solution, the dissolution process of endothermic is endothermic. The solubility should increase with rise in temperature, and if it is exothermic, the solubility should decrease. This trend are also observed experimentally. So now what they are saying, in general we are able to make a conclusion that nearly saturated solutions which are almost like close to being saturated, what will happen? The dissolution process is what? Endothermic, correct? Now, the solubility should increase. What will happen? The solubility will increase. Why? Because we are raising the temperature. On raising the temperature, it will go to exothermic reaction. And if it is an exothermic reaction, the solubility should basically decrease. Now, effect of pressure. Now, pressure does not have any significant effect on solubility of solids in liquid. It is so because solids and liquids are highly incompressible and practically remain unaffected by changes in pressure. So, what they are saying, pressure does not have a very significant effect when it comes to dissolving solids in liquids. This is because the solids and liquids, they are highly incompressible and they remain unaffected by changes of the pressure. Now, solubility of gas in a liquid. Now, many gases dissolve in water. Oxygen dissolves only to some extent in water. So, one we know that oxygen is there in the water. So, it is dissolved oxygen which sustains all aquatic life. That is dissolved oxygen we know, DO. That is what is that is the reason why aquatic life is sustainable. On the other hand, hydrogen chloride gas is highly soluble in water. So, other hand, what we have? We have HCl gas that is also very highly soluble in water. Now, solubility of gas in liquids is greatly affected by pressure and temperature. So, solubility of gases, it is affected by what? Pressure and the temperature. The solubility of gas increases with increase of pressure. Now, what they are saying is that when we talk about pressure with reference to solubility of solids in liquid, we said it was not having a significant effect. But solubility of gases, when we are talking about solubility of gases, it will increase with increase in the pressure. For a solution of gases in solvent, another system as shown in figure 1.1, this one, the lower part is a solution and the upper part is a gaseous system at pressure P and temperature T. So, what they are saying, this lower part is the solution and this is the pressure part. Assume this system to be in a state of dynamic equilibrium, that is, under these conditions, rate of gaseous particles entering and leaving the solution phase is the same. So, what is happening? What they are saying, that dynamic equilibrium, when we say, here we are saying that the rate of gaseous particles, the particles of gases that are entering and the ones that are leaving the solution are same. Now, what we are doing is that we are going to increase the pressure over the solution phase by doing what? By compressing the gas to a smaller volume. Okay, so we are compressing the gas. Now, what will happen? This will increase the number of gaseous particles per unit volume over the solution. So, what we are doing? We have reduced the volume. So, what will happen? The number of molecules of gases that are there, they will increase. And also the rate at which the gaseous particles are striking the surface of solution to enter it. the solubility of gas will increase until a new equilibrium is reached, resulting in an increase in the pressure of gas above the solution, and thus its solubility increases. Now, Henry was the first one to give a quantitative relation between pressure and solubility of a gas and in a solvent, which is known as the Henry's law. So now let's see what this Henry's law states. So it states that at constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of liquid or solution. So what they are saying, solubility of a gas in liquid is directly proportional to the partial pressure of the gas that is present above the surface or above the surface of the liquid or solution. Dalton, a contemporary of Henry, also concluded independently that the solubility of gas in a liquid solution is a function of partial pressure of gases. So similar thing also Dalton had said, that what they are saying, both of them are saying the same thing, that the solubility of the gas, it will be directly depending on what the partial pressure of the gas that is present in the liquid or the solution. If we use the mole fraction of a gas in the solution as a measure of its solubility, then it can be said that the mole fraction of gas in the solution is proportional to the partial pressure of the gas over the solution. So what we are saying, mole fraction, that is the number of moles upon the total volume of total number of moles in the solution. So that they are saying is now directly proportional to the partial pressure of the gas over the solution. So the most commonly used form of Henry's law, it states that the partial pressure of gas of the vapor phase, that is P, that is proportional to the mole fraction of the gas X in the solution, and this is expressed as P, that is the vapor pressure, equals to KHX. KH is the Henry's law constant we have, and X, if you see, that is the mole fraction of the gas that is given. Now, different gases, they will have different values of KH at the same temperature. Thus suggests that KH, it is a function of the nature of gas. Depending on the type of gas, the KH value will change. Okay. Now, this Henry's law has found several applications in industries, and it explains some biological phenomena. One of them is what we do to increase the solubility of carbon dioxide in soft drinks. We know that our carbonated drinks, they have this carbon dioxide gas that is present, and soda water, the bottle which is there, it is sealed under high pressure. So that is why when you open it up, it opens with that a very a loud sound of some gas being released. That is because here it is stored under, or it is compressed under high pressure. Now, scuba divers must cope with high concentrations of dissolved gases while breathing air at high pressure underwater. Increased pressure increases the solubility of the atmospheric gases in the blood. When divers come towards the surface, the pressure gradually decreases. This releases the dissolved gases and leads to the formation of bubbles of nitrogen in the blood. This blocks capillary and creates a medical condition known as bends, which are painful and dangerous to life. So now what they are saying is that the scuba divers who are there, they must cope up with what? High concentration of dissolved gases, okay, because they are having these packed cylinders which they carry, and these packed cylinders, they have a high level of other gases as well. They have these dissolved gases as well. So what happens is that while breathing in air at very high pressure underwater, we know the pressure increases. The increased pressure, it increases also the solubility of the gases that is present in the blood. Now, when the divers, they come to the surface of the water, what happens? The pressure will gradually decrease. It will come to normal level. This release the dissolved gases. So now, when the pressure is coming back, it will release the dissolved gases. This will then lead to the formation of some kind of bubbles of nitrogen in the blood, and if there is a bubble in the blood, it is one of the very dangerous cases. So this blocks the capillaries and creates a very intense medical condition that is known as the bends, which are very painful and they can be very dangerous to life. To avoid bends as well as the toxic effects of high concentration of nitrogen in the blood, the tanks used by scuba divers are filled with air diluted with helium, and helium, nitrogen with helium. Okay, so they, instead of these nitrogen ones, they prefer to use helium, which has around 11.7% helium, 56.2% nitrogen, and 32.1% of oxygen level. Now lastly, at high altitudes, the partial pressure of oxygen is less than that at a ground level. This leads to high concentration of oxygens in the blood and tissues of people living at higher altitudes or climbers. Low blood oxygen causes climbers to become weak and unable to think clearly, symptoms of a condition known as anoxia. Now let's look at the effect of temperatures. Now we spoke about the effect of pressure, now we'll see about the temperature. So solubility of gases in liquids, it decreases with increase in temperature. When dissolved, the gas molecules are present in liquid phase, and the process of dissolution can be considered similar to condensation, and heat is evolved in this process. So what we are saying, when the solubility of gases in liquids, it decreases, what will happen? The temperature will be rising in that case. Now when the dissolved, the gas molecules which are present in the liquid phase, this process of dissolution can be considered very similar to condensation and heat that is evolved in this process. So we have learned in the last section that the dissolution process, it involves what? Dynamic equilibrium, and thus must follow the Chatelier's principle. As dissolution is what? It is a exothermic process. The solubility will decrease with increase in the temperature. Okay, so that was it for today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.